Dear students, today we'll be learning about georeferencing. That is the first method where we directly insert latitude and longitude information. So for this, first we need to go to RAF. And Before we start, I'm using QGIS 3.8.1 version, which is QGIS Zanzibar. What we'll do, first we'll go to georeferencer. Then we have got all this icon, which is also known as graphical user interface GUI. Here also we can see there's GUI. So first we'll go to georeferencer and we'll open raster and we'll be uploading QGIS map, which is a Chhattisgarh map, and we'll be adding GCP points here. But here we'll be doing it with we'll be inserting latitude and longitude information. So first we need to zoom in. And now it 23. So first point will be taking you will be zooming here and then we'll add point and it's enter map coordinate. This pop-up window has come and it's saying east and north. So remember here east is longitude and north is latitude. So this information you all need to fill very carefully. So east here 81 degree and 23 degree. Now okay. Again we'll pan this map and we'll see the longitude information, that is 84. So at this point I'll add my another point, GCP ground control point. Easting is 84 and 23. Okay. Next we'll go to third point and I'll take this point. So here again I'll zoom in and easting is 84 and north information is 19 degree. Okay. 81 and 19. Okay. So once we are done with adding our ground control points, we'll go to transformation setting, and this pop-up window opens which says transformation type. In this transformation type, I have chosen thin plate spline. You can also go with polynomial 1. Remember that if more polynomial, if you go for polynomial 2, so more GCP points you will need to take, and it will invite more error. So ideally one should choose polynomial 1 or thin plate spline, because in thin plate spline what happens that it exactly takes that point and it stretches the map. So error scope is less here. So here I'm choosing thin plate spline. Resampling method, I'm keeping it as nearest neighborhood method. Then target SRS. SRS is a spatial reference system. So we'll be working on select this globe, and we'll choose EPSG 84, that is EPSG 4326 WGS 84. I'll be selecting this, and then it says output setting, where you want to set your final image. So here I'll be keeping it, I'll be saving it in desktop, and then I'll create one folder, georeference. So here in this folder I'll be saving this map, and save GCP points. This is very optional. If you want to save ground control points for future purpose, then it is very optional. If you want to, then check in this option, otherwise leave it like this, and load in QGIS when done. Okay. After setting our transformation setting, let's go to the start georeferencing process. So we are done with this. One thing you all need to understand here is that residual. So residual, here you'll find that it is in 1, 2, 0, 2.2. So in QGIS, it is residuals are in pixel, and the accepted residuals are less than 10 pixels. So unlike in ArcGIS, where 0.5 is the RMS root mean square error. So once we are done with this, we'll just cross this. Save GCP points, it is asking. Okay, let's save it. Now my Chhattisgarh map is here in map canvas. If I want to say whether it is done properly, I've done it properly. So I'll go to quick map services. I'll go to Google Road. See, it is it is georeferred properly, because now I can see that it is just lying over the, and I'll decrease the transparency setting, apply. Okay, so this is done. Thank you, students. So this is the very first method of georeferencing, that is where we are inserting latitude and longitude information. Thank you, students. Happy learning.